Unit 1 Introduction to Computers. What does the word compute mean? The word compute means to perform the calculation. Earlier, computers were used for calculation purposes. So they were called as computers, and we're still calling it as computer, though it is performing many other tasks. Let's move into the formal definition of a computer. The computer is an electronic device that takes the input and gives output. What does a computer do? It takes the input and processes it and generates output. After taking the input, it stores it first before processing, and then it generates the output. Let's take an analogy of it. Preparing a mango milkshake. How a mango milkshake is prepared? The input is mango, milk, and sugar, and we churn it, and the output is mango milkshake. It is just an analogy. If you understand this, it's better, or else you just leave it. And computer has input and output devices. Input devices like keyboard and mouse. What actually the input devices means? These are the devices through which we give the input to the computer. And output devices are like monitor and printer. There are many input and output devices, but I'm covering most commonly used input and output devices. And computer has something called processor, which is also called central processing unit. The processor has two units. One is ALU, other one is CU. ALU is nothing but arithmetic and logical unit, and CU is control unit. Arithmetic and logical unit performs all the mathematical operations in the computer, and control units controls all other units within the processor. Control unit controls the arithmetic logical unit and the memory unit and any other device of the computer, and it tells them how actually to respond to the instructions within a program. A program is nothing but collection of instructions. What does instruction mean? Instruction means you instruct the computer to perform certain task. The instruction can also be like add 2 3, or add 5 6, or else subtract 5 from 6. Let's take this. 2 plus 3 is also an instruction. 5 plus 6 is also an instruction. 9 minus 7 is also an instruction. This is nothing but mathematical operations. This is just an instruction we give to the computer. The computer computes it and gives us the result. Next, what is a computing environment? Computing environment is nothing but a computer uses various number of devices to perform certain tasks. It's nothing but arrangement of a computers in a certain way to accomplish a certain task. We give the input and the printer takes it and gives the output. This is just the general process how actually the input and output devices work. When it comes to the computing environment in particular, we have different computing environments. One is personal computing environment. Personal computing environment. Let's move to the other page. It's better. Personal computing environment. Personal computing environment is nothing but these are personal computers within our home, or else let's take anything like, okay, let's take a mobile, or else personal computer, laptop, every other device we use for computation. We regularly use this thing, right? This is a personal computing environment. And next, we have different computing environment like time sharing computing environment. Today in computer we are able to perform different tasks while listening to the music, and we can send an email, and while sending an email we can actually play a video. We are actually doing a multitasking. The process of multitasking is possible because CPU time is shared between uh, different applications. So this is how we are actually achieving the time sharing computing environment. And we also have distributed computing environment. I'm not actually giving the notes, I'm just saying it orally. Just understand this. Okay, let me just draw the diagrams so that it would be much easy to understand this. Just a normal computer, personal computing environment, mobile. This is nothing but a personal computing environment. Time sharing is something like email, uh, songs, videos, CPU. You can perform multiple tasks on computer. Like while sending an email, you can listen to the songs and you can watch videos. This is nothing but multitasking. We are able to achieve because we have computers that have time sharing environment. The CPU time. See, the CPU's time. The CPU has one time. Like the CPU time is shared among these processes. I tell you about what is a process later. Now let's understand this as applications. So we can perform multiple applications simultaneously because of time sharing environment and distributed computing environment. Distributed computing environment is something like uh, the single software is run on different system to achieve a particular task. Let's take the example of a Facebook. Facebook is not run on single system, right? Let's understand this. Facebook is an application. It contains multiple programs. Different programs are run on different systems. They collectively try to achieve one single task. They're able to perform every other feature that is available on Facebook. This is available because of distributed computing environment. Not just Facebook, even Google works in this way by using distributed computing environment. See, whenever you search on Google, uh, it is the information is not available on single server. I mean single computer. It is ever This is distributed among different computers. So what does the Google have to do? The Google have to send your request to the multiple computers. They process it and gives you the output. When it comes to the uh, distributed computing environment, we can go in depth, but it is not necessary. You just know this thing. Distributed computing environment is nothing but the software is not run on a single system, it is run on multiple systems to achieve a certain task. I said you the example of a Facebook. The Facebook must be having many features, but whenever you actually want to use the Facebook, it is not run on a single system, it is run on multiple systems. It is distributed across multiple systems. They together able to perform or attain a task. And next, grid computing environment. You must know this thing, grid computing environment. This is quite common these days. Okay, this is used along with cloud computing these days. See, grid computing is a collection of computers from different locations. All these work together for a common problem. A grid can be described as a distributed collection of large number of computers for a single application. See, just like distributed systems, a grid computing environment is a kind of distributed system. Let's suppose we can actually presume like grid computing environment is something like a computer with multiple processes, or else different computers distributed across the network to perform a single task. See, just remember this, the Facebook application. You would be very easy to understand this. See, a single computer, the computation power is pretty less. Let's suppose we consider this thing. A computer can perform certain number of tasks. Let's suppose a computer can do run 1,000 applications at once. One computer. Let's suppose if there are three computers, they together can run 3,000 applications, right? This is what this is what we do in grid computing. Don't just get confused between distributed computing and grid computing. See, grid computing is used to achieve many tasks at a time, but distributed computing is used to actually run a single software. For a single software, we distribute the programs across different computers to attain the task. And next is cluster computing environment. What is a cluster computing environment? Cluster computing is a collection of interconnected computers. These computers work together to solve a problem. In cluster computing environment, a collection of systems work together for a single system. See, you might have seen what does grid computing mean, and you want to know about what does cluster computing mean. Cluster computing is nothing but the same like grid computing, but this is distributed across a local area network. See, we have two networks: local area network and wide area network. See, local area network is distributed less than 1 kilometer, and it is greater than 1 kilometer. Let's suppose an office space, like a building, can have a LAN, but entire city do have WAN. This is what cluster computing mean. See, don't get confused between distributed computing, grid computing, and cluster computing environment. See, distributed computing is used for a single application, and grid computing is used for multiple computers. And cluster is same like grid, but it is geographical area is less than 1 kilometer. It is used only for LAN. Next, moving into the next topic of your syllabus, computer languages. See, what does actually the computer language mean? See, computer understands a certain language, right? See, in order to communicate with another person, let's suppose I know English. Yeah, other person whom I know is also knows English. So we can both communicate with each other using the common language English. Let's suppose you want to communicate with computer. See, computer has a certain language, like, right? See, computer using a computer. See, you have to have to communicate with the computer using a language, something like C programming language or Java, whatever the language. See, computer has a certain language, so you have to know that language to communicate with the computer. So, see, let's suppose you want to instruct a computer to do a certain task, so you have to use these programs. See, you have to communicate with the computer. Let's suppose this is a computer. Yeah, with the computer only by using a computer language. See, a computer language can be C, Java, anything. This is what the introduction about the computer language. Let's learn about C programming language in the part 2 of Unit 1. Now let's understand what is a computer language. See, when it comes to computer language, what kind of language do computer understand? See, the computer doesn't really understand C, Java, or else any other language. If we go in depth, it understands only a binary language. This is also called machine language. See, this is nothing but zeros and ones. This is a logical representation. Inside the memory, they are represented as the charged and uncharged particles. See, charged and uncharged. Charged is 1 and uncharged is 0. This is how it is represented within the memory. And binary language, we have seen this. See, just understand this thing. Don't get confused. See, computer language is nothing but this is the language using which we can communicate with the computer, whereas computer can understand only this language. See, we have a certain language. This language is converted into the machine language, and that machine language is given as an input to the computer. See, let's suppose we program in C programming language. That has to be converted to machine language. That has to be given to the computer to give the result. See, this is what the basics of computer language. Now let's move into creating and running programs. See how you can actually create the program. See, you write the program in an editor like Turbo C, C++, Turbo C++. Yeah, we can use C or C, Turbo C or C++. See, we need an IDE is nothing but integrated development environment. This is the workspace where we actually write the programs and how we can run it. See, I'm not actually getting into the C programming language just now, okay, right now, because when we actually move into the introduction to C language, we can learn how actually these things works. So initially you would be having a vague idea because I'm making this video with an assumption this you doesn't know anything, you don't know anything. With an assumption you don't know anything, I'm starting this video. So don't mind, you would get a clarity at the end of this course. Just keep watching it. Introduction to computer science. Yeah, in this introduction to C language, we will see this thing. Next, how you can actually run programs. See, you create the programs within this editor, and we run this within this. Next, program development. See, I just said you this program is nothing but set of instructions, right? If program is a set of instructions, how we develop it? See, program is nothing but instruction that we want to give to the computer. How we develop an instruction? Uh, Whenever we want computer to do certain actions, we have to write down the instructions. Before that, we want to know what kind of instructions we want to give. Let's suppose you want to ask a person to slice onions, to cut the onions. Just give an instruction, cut onions. Or else you want to prepare a curry. You should know what are your requirements. Only then we can create the program. See, after knowing the requirements, we write the program using a certain language and we run it, and we get the result. And algorithms and flowchart. And what does an algorithm mean? See, an algorithm is a step-by-step process of defining a problem. Let's suppose we shall take something like doing a particular task like go buy groceries. So what is the requirement? First, note down what you need. Then walk to grocery. Then choose items. Pay money. Collect items. Bring home. See, this is what our problem. See, go and buy groceries from a shop. So what do we do? We do all these steps. It's nothing but you define your problem in a step by step process. And flowchart is nothing but pictorial representation of a flowchart. Flowchart is nothing but pictorial representation of this algorithm. See, we have few symbols for a flowchart. This is start or end. This is nothing but take input. This is to process. See, this is input or output. Process. And again we have decision. Rhombus or diamond we use for decision, and we use a connector. Let's define this thing. First of all, start. See, I'm not using the programs to explain this flowcharts because we shall understand these topics later in depth after we actually start the programming. Let's understand what the basic definition is. What is a flowchart? Start, and so take the input. Like, okay, note down